Okay, so for limits of a function, the graph method, this is basically how we're going to do it. So limit notation is basically, the way I learned it is that it's the relationship between x approaching whatever value. That's the limit, okay? Let's pretend that this is the limit. This is what you're being told. Whenever it approaches whatever value, we're trying to figure out what f of x is, which is like saying y. So the way that I learned it is the limit notation is basically the relationship between x and y. As x reaches whatever number, what is happening to y at the same time, which is f of x. So for example, limit, let's say x is approaching 0, because that's the easiest. What is happening to f of x, so y? So on the graph here, let's say 0 right here. This is 0. If it's at 0, it looks like it's about like 1.5, roughly, at 0. Basically, we're just looking at when x is getting closer to 0, what is happening to the y? Well, if we look at it, if we pretended that there was like an imaginary like dotted line all the way here, let's do that in marker. If there was like an imaginary dotted line all the way down 0, and it split the graph into 2, what is happening to y on either side? Well, if it's coming in from the left, it's still going to be at -1.5. If it's coming from the right, it's getting closer to -1.5. So f of x would equal to -1.5. I hope that makes sense. The reason that we can disregard this is because they're not really overlapping. It would be a different story if, like, let's say, let's write it with a pencil. Let's say that the other graph was like this way. At this point, there's two things crossing 0, and they're not exactly the same. Like, if there was a, let's say, a -3, 2, and the opposite, let's choose here. -2. Oh, no. +2. Oops. -2, 2. As it's approaching, it's a different number for 0. This is at 0, whereas this is at 1. At that point, f of x would equal to d and e, which means doesn't exist.